natural. It's just half because it's 1 out of 2. It's 180 out of 360. And then to find this arc, I will just halve my 2 pi arc. Okay? So this is natural to do. But what if I give you a small segment of it? Then I say find this one. What's the first question you will ask me? What is the angle? Because you want to know what fraction of it. So if this is theta, then I will just say, oh, whatever this angle is, I don't care. It's out of 360. Then I know what fraction of the circle we are talking about. And then you multiply by the circumference. Then you get the arc. So this formula is derived from your understanding of fraction. So you don't even need to memorize it. Okay? So, although they say this is arc length formula, but you should know. Okay, you should know. Okay, so they say I have a radius of a circle, center at O, and it is 8. So I have an arc CQD, subtends an angle of 135 at the center. So 135 maybe like this. So they say this one is probably CQD. Okay, this arc. Okay, they call it CQD. And it subtends an angle of 135 at the center. So can you find the length? So what is the length of this blue arc? 135 out of the 360. I times 2 pi r. That's all. Okay, so it's what fraction of the circle are we talking about? Okay, arc is the length. So 3SF for non-exact answer. Okay, if question asks you to leave your answer in terms of pi, then it will be 6 pi cm. This is if they ask you to leave answer in terms of pi. Okay, you have done this in Sec 2 before. How to evaluate something in terms of pi? Ignore the pi, key in everything else into the calculator. Then leave the pi alone. Okay? Yes. Okay, but actually no need to memorize one. It's like known. Okay, next one. I have a minute hand of a clock that is 10 cm long. So we have to make that assumption that the minute hand just spans the whole thing lah, huh? Okay, so 10 cm long. They are trying to tell you is the radius. So how far does the tip of the minute hand move in 40 minutes? So you must have that understanding of a clock. 40 minutes out of a total of 60. You cannot die, must be 360, right? So 40 minutes out of the 60 minutes clock. This is the fraction I have. Okay, how far has it moved? I'm trying to find circumference. So 2 pi r. So again, so answer is 41.9 cm 3SF. Okay, if it's in terms of pi, it's 40 out of 3 pi. Okay, then they say how long will it take for the tip to move 30 cm? So now instead of giving you how much, instead of telling you the fraction of it, they tell you the actual length. So now they are saying, oh, the length I've moved is 30 cm. So what you don't know is the fraction. You don't know the fraction. You know it's still out of your circumference. Okay, and it's equals to 30. So the fraction is what you don't know, but you know it's out of 60 definitely. So you want to know what is this part. Okay, so solve it like as if it's a normal algebraic question. So to find x out of 60, you divide the 30 by 2 pi 10. Okay, so x is just 30 times. Okay, 28.6 minutes.
How do we find that?
Do we find the?
I'm trying to get the formula, right? Like, how do I get this?
You can use cosine rule, you can use anything to help you to find. Yeah, it's all linked. Yes. Because one full round here, we are talking about in terms of minutes, time. So one full round is 60 minutes. So to cover 40 minutes, what fraction of it will that be? So 40 out of 60 is 2/3 of the clock. Yeah, so if you just imagine from U12 moving to 8, yeah, that is the proportion that you have moved. Because 40 minutes will move up to 8, right? That's 2/3 of the circle. So I don't know the fraction, but I know that this fraction times 2 pi r will give me 30. So I'm trying to find the fraction here. So if I divide 30 by this will help me find what my fraction is. So if I just stop here, I know what is my fraction, but I want to know what is the actual time. So I times the 60 over. Yeah. Okay. Yes, I can. Okay, then next one, they say the curve of a road is an arc of a circle whose angle at the center is 135. So when they draw the diagram for you, it's easy lah. So the length of the curve is 35. Find the distance of the curve from the center. What they are asking you to find? Did I calculate wrongly? 2 pi 10 times 60. Correct, 28.6. You check. This one, this whole thing. Do you times the 10 or not? Okay, what is the question trying to ask me to find? Distance of the curve from the center. The radius. So actually what they want me to find is what is the r. So I put my normal fraction into play. Is 135 degree out of 360. I multiply by my circumference. It should give me 35. So there's only one unknown here. So you go and divide everything over, okay, with your 35. So divide this whole chunk over, okay, and then get your answer. So 3SF 14.9 meter. Okay? So quite easy to understand, right? It's fraction of a circumference. Okay, next one is if we move on to sector. It's also the same thing, but now it's a fraction of an area.
How do I simplify this? It's like damn complex.
No, you must find this sector first.
This one minus this one plus this one. So it's like
No, you just theta over 360 times pi square. You get this piece. Then minus half AB sin C can. Yeah. Yes.
It's like this one. I use a different method to find the time. And then I got the first part, but then the second part.
Per minute, what degree is it?
Yeah.
So you find the angle. Then out of 360 ma. Okay, next one. It's area now. Quadrant. 1/4 of a pi r square. So what about that sector? Yeah, so we find that fraction times pi r square. So it is like your arc length, but just that now we are talking about area. We change the 2 pi r to pi r square. And this number that we have here came from the idea of fraction. This is one whole. Okay, we are all finding a fraction of it. So half is a fraction, 1/4 is a fraction, theta over 360 is also the fraction. So this is the formula. No need to memorize. You should know. Okay? So don't say a lot of formula to memorize. This one is understood. Okay, so area of sector as seen from what we have there is find the fraction of the circle times pi r squared. Okay, so the minor one is easy. I just want this slice, right? So what you can do is theta over 360 times pi r squared. But what if I want the one outside? What will you do? 360, I take away the angle. So I found this. This is 360 minus theta. And then I over 360. That will help me find the fraction of the circle, right? And then I times pi r squared. Okay? So you go and find the angle subtended by the major sector. And then you will be able to find that big fraction. Alternatively, we can also find area of circle minus away the small one. Okay, this will also work. So this is an alternative way. Okay, the reflex we have found is 360 minus theta. So if this angle is theta, the reflex is the one outside. Okay, so very easy. Can you just very quickly do the example 1 and 2 on your own before you check against my solution on the screen? You try on your own first. So they put a Q there so that you will turn here. So it's the major sector. Okay, they want the major one. Okay, they say minor sector, then you find minor, huh? Okay, example 2, they say leave your answer in terms of pi. So you can leave it like this. Okay, or if you prefer mixed number. Okay, quite simple, right? Okay? So we only ask you to find 3 things. Arc, sector area, segment area. Minor or major. Okay? And then sometimes we can put in cosine rule into the triangles and make it a bit more interesting. Okay, that's all we can do. Yes. Trigo. Can. Yes. Okay, last type, last type. 16, 8/9. Pi. Okay, just to recap, segment means the portion of the circle that is cut up by the chord. So chord is formed by any 2 points of the circle, okay, when you join it together. So this is a minor segment. Okay, this is the major one. Okay, but we can always add in details because it can come from the center. Right? So this segment that we are interested in finding, we can always go and find the area of the sector first, and then I take away the area of the triangle, which I know how to find. Okay, so to find area of the sector is this one. Okay, remember just now, I will use area of the sector first. This one how to find? Assuming this theta. Theta over 360 times pi r squared. So that is that slice. But I'm only interested in the final output, which is here, this part. So I need to minus this triangle. How to minus triangle? What is the area of triangle formula? So the A and the B here happens to be radius. So it's half r squared sine theta. Because half times A times B times sine theta. The A and the B, they are all r's. Yes. So with that, if I subtract them, I get the area of segment here. You try? Okay, this is area of sector formula. Theta over 360 times pi r squared, correct? Okay. What I want to find is the area of this piece of triangle, which is half AB sine C, right? So can you see my A is R, my B is also R, sine is the theta. So that's why I use this formula. Because I'm interested in this green zone only. So the big sector, I take away the triangle. Isn't it that segment that I want? This part here. Yeah, so you need to subtract it off.
To find the major segment is 360 minus theta over 360.
Correct. So, okay, what if I want the major segment? This one. What if I want to find this? Then what do you think I need to do? Yeah. So you can find the big circle, pi r squared, minus of this answer you have. Alternatively, you can first find the area of the major sector first. That means this is 360 minus theta, right? So I will first find this slice, this piece. Okay, I first find this piece. Okay, let me write it up there. So same thing, I have to first find this piece, which I can use 360 minus theta over 360 times pi r squared. Right? So this is the major slice. But I need to add it to the triangle here. Instead of subtracting this part here, I need to add this part. Okay, I need to add this triangle. So instead of subtracting, I need to add half r squared sine theta. Then I get the entire slice. Because what I want now is the yellow one. Minus off that small part. This is the major segment. Right? So to find that, I need this Pac-Man here. You see the Pac-Man? So I need to find the major sector first, which I use this formula to get, plus the triangle. Then I get this entire slice. So if you don't like this, very complicating, you just go and find the normal minor segment first and then use pi r square to subtract it away. So instead of this is major segment, right? So I could also alternatively, okay, use pi r square minus the minor segment, which is this. The formula looks complicated, but the math is direct. Okay, this is for the minor. Just use this to minus the minor segment. Okay? Okay, let's practice that. Don't worry.
This is what I love in life.
Because it's relatable. Okay? Can ah? Okay, this one. Angle AOB. First of all, you know these are both 8. And then they tell you the area of this sector, this whole thing, is 64. So I will use area of sector formula to help me. I let this be theta. Theta over 360 times pi r square. It should give me 64. So the rest is just solving the math. So 64 divided by 64 pi. Okay, and then you cross multiply the 360. Can. You can skip steps. So answer is 114.591559. So long. Okay, never mind. So you leave it like that, but because it's angle 1 dp, so 114.6. So this is the angle we have just found. 114.5916. Okay, for instance. Okay, next one, I want to find the segment, which is this slice only. So what you will do is you will use the area of sector to subtract the area of triangle. This slice, okay, take away the triangle. So you only end up with that tiny part there. Okay, so area of sector, I already know is 64. No need to calculate again. Don't work so hard. Okay, and then I know that this is half AB sine of the angle in between. So half 8 square sine of the angle between them. So 34.902. Okay? So segment is sector minus triangle. So sector is what you know. Can? Okay, those who are looking at example 4, try to split the shape up so that you can see the shapes that you have learned.
So basically, you have to draw a line from O to OC.
Yes.
And find the triangle.
Correct.
And the segment.
Yes.
Then
The sector.
The sector. Then we find the segment.
No need segment. We don't need the segment.
We do.
If you want, you can find semicircle minus the segment. Also can. Yeah. So actually, right, remember, no matter what shape, how complicated it looks like, you must know they won't test you beyond what you have learned. So there must be a sector somewhere. There must be a segment somewhere. Yes. Can. So example 4, if you're at it already, try to divide the shape and then see what you can do about it. And then remember you have radius, you have radius. A lecture, so sleepy. It's just Wednesday, midweek. Did I tell you all I just spent $80 on squishy? Yeah, I cannot believe it. 2 boxes of squishy. I'll take a photo and show you all when it arrives. I just cannot believe it.
What type?
It's 1 box of a lot of don't know what nonsense inside. And it cost me $80. Oh, my daughter bought it. Because she said, if I get this for my WA, then you must buy this for me. I said, okay, sure. Then she really got it. So, but the thing is, I'm very sure that all of it will be in the dustbin one of these days. So my $80 is like, you sure you want the dusty and I cannot understand.
Is it the tiny squishy?
A lot of like look like bread, look like don't know what, look like I don't know how to explain. With the extent that people go to earn your money with glue. TGIF, thank God. No, it's Friday. Yeah, why?
It's like a auntie term. I learned it last week.
Auntie term. He turned one whole round and say because I know I'm an auntie. Horrible. Yes. I will not do that. I won't harm other parents. Okay, anyway. AB is the diameter. And then radius is 10. CAB is 60. Find the area of the shaded region. So as mentioned, right, there are 2 ways to approach this question. Number 1, I first find area of semicircle. Okay? So I find the semicircle and then I minus the tiny segment I see there. So this is one way. Another way is I can split this shape up. Okay, and knowing that this is radius, I know this is 60. This is also 60. This one angle here is also 60. So it becomes an isosceles and then an equilateral triangle. So I can find this, which means I can find this as well. So this is 120. So I can find this in 2 parts. So I find this one first. Okay, and then I add it to this triangle. So this is another way you can approach the problem. So I can plus this to the tiny part. So if I'm using this, then I will pi r square divided by 2. Semicircle, right? Okay, then, I wrote at the wrong place. So this is pi r square divided by 2. Okay, so how to find this segment here? I will need to engage the help of my formula. So it's theta over 360 times pi r square, and then I subtract my triangle, half r square sine theta. So I subtract these two, I will get my answer. Alternatively, I will use 120 over 360 times pi r square. And then I add it to this triangle, which is half AB.
This looks better.
Yeah, so whichever feels better and easier for you, okay, is good enough as a method. So you either find semicircle and then you minus off that tiny segment, or you find the sector plus to the triangle. So whichever the case,
You have like 9 minutes, right?
okay, that's good enough for the next question. So So 3SF 148 cm square 3SF. So method 1, method 2. Okay, both are equally good method as long as you get the same answer. Okay, last one is their favorite. They like to ask fan shape. Okay, this is the fan shape that they like. But no matter what, remember, it came from a circle. No matter how they draw it. Okay, this came from an original circle. So it is a sector of a big circle minus of the sector of a small circle. So if you can see this shaded part, it is area of big sector minus area of the small sector. And both of the angles subtended by the whatever arc that we have there is 144 degree. So we are talking about 144 out of 360 times pi. My r for the big circle is 5 plus x. Okay? So the small one is the same fraction, no change. Okay, but just that my radius is smaller. It's only 5. Okay? And they tell me that this is the equivalent of 30 pi. So based on what they have given you, they say, can you then solve for x? So first thing, of course, I want to simplify the problem by dividing everything by pi, so that the pi is gone. I don't have to deal with pi anymore. Okay? Then I will simplify the numbers only. So this is the complicated part. I will just 144 divided by 360. Okay, it's 2/5. So if you don't want to deal with fraction, you can write 0.4 so that it looks friendlier. Okay, 144 out of 360 times 5 square. This one ends up with a nice 10. So simplify the math. Bring the 30 over. Bring the 10 over, become 40. Okay, don't be eager to expand. I see bracket, you must expand. No, wait. See whether you can solve it easily or not. So they won't want to test you algebra here. So they won't try to kill you with the math. So don't be very eager to expand and complicate the problem. So actually at this juncture, right, you can take a square root already. You don't need to expand and solve quadratic formula. But if you like, it's okay. Okay, so 5 plus x, you will get 10. Or 5 plus x is negative 10 when you take a square root. Two possible answers. So x can be 5 or x can be negative 15, which is nonsense, right? So you reject the negative 15 and x is just 5. So the content is here. What they want you to establish is this part. The critical part is not the solving, because this is just an end product of it, a byproduct of it. Okay, but what they want to test you is the formula at this point. So just make sure you do that properly and then get the answer. Okay, so we have a 5 minute. You can do the PMP. No need to do on foolscap paper. Just do it on the space provided and then check whether you get the answer there. So we will continue the next lesson. So the 5 minute you can start doing PMP. Practice your understanding. That once you found the angle, you can find the shaded region by using the formula. So theta over 360 times pi r square, and then minus half AB sine of the angle. So your 60.0, don't use the 60.0, use the more accurate one, which is this one, 60.024. You should be able to get the answer there. So that's question 3. Okay, I just want to point out for question 4, right? To find the area of the shaded region, you can find area of segment here and then area of segment here and add up. or you can find the area of the semicircle, take away the area of this triangle. So if you look carefully, I can find the area of semicircle by using pi r square, half it. Right? And then I already have the two sides of the triangle, which is this WX I found just now. And then this is the diameter, which is 30. So the angle in between is known to me. I just half AB sine C. So you do a half AB, use the more accurate one. Okay, sine of the angle in between. Then you should be able to get the answer up there.
Wait, I'm almost done, guys.
He's showing you what is never give up.
I found the answer.
Should I play the song? He's demonstrating, try everything. Later during break I play, okay?
I think round off is true.
I think that's why we score very well in W1.
Okay, so you will get 142, 3SF for your answer. Later during the break. We must finish this chapter today. Yeah, we can. Good. So short your look.
I'm not looking at the answer. Yes. No.
Shit. Yeah, so it's like the two. It's like.
To what?
Is it like the? Remember?
Let's go. I
5,
did
right?
it.
Yeah?
You did.
Yes,
What are they talking about?
because of radius. These two are your radius.
Is this like primary school though? That one? Like,
I
you know
did
how,
it.
Like quadrant is 1/4.
Yeah. 1/4, yes.
That's so easy.
Yes. Okay, so next one is this one.
This one, I think I finished that question.
Yeah, this one, right? Okay, let me go through 5. So you all should applaud his effort, right? He really never stop trying.
Thank you, guys. I'd like to give thanks to Raj, my calculator.
Okay, AOB is quadrant. So if it's quadrant, this thing is 90 degree. Okay, that's number 1. Second, they say the radius is 7. So you know this full length is 7. Okay, then they tell me that C is the midpoint. So that means this one cuts this arc length into 2 equal half, which means this is 45. This is also 45. So this is an important info. Okay, knowing that this is 45, we can focus on this triangle. Okay, to find the height and the base. So this is also radius. So this is 7. So I told you all before, right? The shortcut is this is 7 cosine 45 degree. This part here, the top part is 7 sine 45. Okay, but if you look at Ashrel's working here, both are sine 45. Okay, because he switched it to the other side. This one is 45 degree, so it's also 7 sine 45 here, 7 cosine 45 here. So it just so happened that on the calculator, right, cosine 45 degree and sine 45 degree is the same value. So even if you see 7 sine 45 here, 7 cosine 45 here, it's the same answer actually. Okay? Because this is 45 degree. That's why both are of the same length.
Wait, Miss Mom.
Yes. Processing.
Wait, how can the hypotenuse be equal to the...
That's what she was asking just now. By the way.
This one. This hypotenuse is the radius of the quadrant one. No matter where it is, it's always the radius. So it's 7.
Well, how can it be equal to...
What if I'm high on the news?
It's not equal. The other two sides.
Oh, because they're not radius, right? Oh.
Yeah. So this part here is 7 cosine 45. This part here is 7 sine 45. Okay, shh. So my objective is to find that little shaded part, right? So first of all, I need to find the area of this part. Okay, this part, which is 45 degree out of 360 times pi r square. So this is the part, right? I need to find the full sector area, this whole red portion. Okay, then I subtract off the triangle, the right angle triangle, which I know the height and I know the base as well. So I can do a half times base times height. So my final answer would be the difference between these two numbers. So if you go and calculate properly, okay, it should give you an exact 7 cm square. Okay, you double check. Okay, but you must take this to be 22/7. If not, it wouldn't be exact. Okay, so this is all for the degree. So now we are going to change to radian mode. It's just like instead of asking you to calculate everything in centimeters, now I'm asking you to calculate everything in meters. So it's just a conversion of unit to another angle unit that we will learn now. Okay, so I'm going to, yes, it's radian. So let me just apply. Oops.
Radius kind of like X.
It's like a distance.
What do you mean?
It's like a distance. It's like a length. Okay, maybe I'll say it is a length. Okay, so 180 divided by pi would be the length covered by 1 radians.
Oh, so then if it's 2 radian, it's 180 divided by 2 pi.
Correct. No, times 2. This whole thing times 2. So first thing first, if I have 135 degree, I know that 180 is pi radian. So 1 degree, just like your primary school way, right? You will go and find 1, like how you will do ratio or rate. And then 135 will be 135 times this. Yes. A unit. It's just a unit. Like 1 meter, you straight away know times 100. Then you know how to convert to cm. So this is the same thing. So this is so that we can actually know what is the, it's just another way of measuring, a more convenient way of measuring. So this tells me that this tells me that if I'm around a circle, like how you're running around the earth, right? Although it feels flat, if I have covered 135 degrees. Oh, too much. Here, 135 degree. Okay, around the circle, I would have covered 2.36 radians. Okay, I will have covered a distance of 2.36 radians. Okay, that's the unit that they represent it with. Did they say in terms of pi? Oh, if they say in terms of pi, then don't need to evaluate. Just give me the 135 over 180. So you should get 3/4 pi. So just evaluate the calculator, right? Just evaluate the shaded one and then leave this as this. Okay, can you repeat the same thing for B and example 2? Yes. Why? Oh, you want you can lah, but it's the unit ma. Not compulsory. At the end, we write RAD as like units for cm, for meters, for kilometers. So we will write it as RAD because that's the units.
So that means like if the question asks, leave it in units of RAD.
They will say find the angle, but if everything is in terms of radians, your angle will be in radians. It wouldn't be degree. Later you will see an example. Okay, so just learn the conversion first. So same thing, 180 is pi radian. Just like 1 meter is 100 cm. Okay, you remember this, you use it for your conversion. So 1 degree is pi over 180. So 210. Yes. Just what? Can. You can still always skip and give me the answer. Okay, just like this. RAD is the unit. Okay, it's the unit like cm.
Job. Sine square theta plus cosine square theta is 1, right?
Sine square theta, yes.
But how do I change it to
Like what?
when they give sine theta minus 1, right? How do I change it to sine square theta plus cosine square theta? I kinda get it.
Wait, let me. This one is identity, chapter 11 already.
Oh yeah, again.
Okay, so if you want to skip steps, you know it's always the angle times pi over 180. Okay, if you want to skip steps. Yeah. Example 2. Oh, they want the angle in radians. Okay, sorry. This one never say in terms of pi, right? So pi divided by 4. Okay, remember radians is like distance. So you leave to 3 SF, not 1 dp. So it's 0.785 rad. Okay, 3 SF for angle in radians. It's like distance covered around the circle. So it has to be 3 SF, not 1 dp. Yeah? Okay, conversion is just rarely they will ask you to convert though. Rarely. If it's from radian to degree, it's very easy.
You know, like let's say you see this, right? Sine 60, and then you get this number, right?
Yeah.
But then
You square it.
Square it like this, then I get 3 forms. So is it sine 60? Can I say sine 60?
Square root 3 over 2. Yeah. You memorize it. Actually.
I don't want to.
Okay? Can Okay, what if we give you radians and we ask you to convert to degree? So same thing. We know that pi radian is 180 degree, right? So 1 radian is 180 over pi. So to find 7 pi over 4 radian, you basically times this. Okay, you basically times this. So same thing here. Okay, if you are unsure whether it's pi over 180 or 180 over pi, always go back to this. Yes. You can 360 lah, but it will be 2 pi. Yes, always. It's just like 1 meter is always 100 cm. Okay? So this is 315 degree. Yes. Because I want to convert this to 7 pi over 4. Okay, if you don't want to skip step, from here is 7 pi over 4 rad. So you must times this. Okay, so you run through the steps. Okay, but if you want a quick way, then it's multiplying by this straight. So this is converting to degree. If you convert to degree, you multiply by this. If you convert to radians, yes. Yeah, 269.3, yes. 1 dp. Angle is 1 dp, radians is 3 SF. Remember that. Okay, I try not to ask y'all to memorize this because sometimes y'all will forget the order and get it wrong. Then the error gets spilled over to all the parts. So it is always good to fall back on this. There is, but it can have a snowball effect on what you have.
But there won't be error carried forward because ECF is only for the, like, if the final answer was wrong, right? So if your formula is wrong, they won't be.
So let's say your angle is calculated wrongly, but you find angle of sector, angle of segment using that wrong angle. There's still method marks carried over. Yeah. Okay? Okay, now the highlight. Now the highlight. When you see angles with sine, cosine, tangent, and the angle they put there doesn't have a degree symbol. So take note, your calculator now has to be changed to radian mode. Okay, your calculator has to be changed to radian mode. Okay, wait, give me time. Radian mode. So let me go to the calculator that you have. When the angle is in radians. Okay, wait. Okay, so how to tell? Normally, when I ask you to calculate, okay, wait, let me shift this to one side first. Normally, when I ask you to calculate tangent or sine or cosine, right, it's always something with a degree symbol there. Tangent 30 degree, tangent 45 degree, tangent 38 degree. But when you start seeing numbers inside in terms of pi, or it has no degree attached to it, you know this angle is in radians. This is measured in radians. Then that is where you need to start changing your calculator to radian mode. Yes. Not a nice number doesn't matter, as long as it doesn't have a degree symbol attached to it. Yes. Yes. Okay. So, to show you, okay, let me go there. How to go in? Okay, so to change to radian mode, right, you are expected to go and press shift. Yeah, yours is. Oh, is it? Okay, wait. Where is your setup button? Shift setup. Okay, shift, then followed by the setup. Oh, mine is different. Okay, never mind. Let me. This is a ratio. You can also leave it as 3SF. Okay, it's a ratio. Sine, cosine, tangent, the answer you get is always a ratio. Tangent is the ratio between O and A. Sine is the ratio between O and H, and so on. So all these are ratios. It doesn't have units attached to it. No rad, no degree. Just ratio. Okay, then how to find the angle? When you see that they say the angle is between 0 to pi over 2, you know your angle is in radians. Because if not, they should have written theta is between 0 to 90 degree. But if they have written in terms of pi, you know your angle is in radians. So when you take inverse, you also make sure your calculator is in radian mode.
So if you see a pi in the
Yes. Yes. So cosine inverse 18/27. Use radian mode, and then you will get the answer in radians. So the answer you get is this one. Because it's in radians, make sure it's 3SF. So the unit is rad, 3SF. So these are the fundamentals. Make sure you get that right. Yes.
I accidentally changed this one. So which one is it supposed to be?
No leh. Shift setup, angle unit, radian.
I went here and then press 1 and then press 2.
One is input output. 9190. The first one? Yeah. So 3SF 0.946. So remember your unit is red 3SF. Okay? Can so these are the simple conversion. Make sure you know how to convert them.
Do you have a
Correction.
I was like, I'm just drawing. Is this one right?
What is this?
The triangle for ESDC, the reference angle.
No, it's like a fish. Basic angle is like a fish. Like alpha like that.
Now I was thinking whether it was this one or it was this one.
This one.
This?
This. Yeah.
Yeah, like a fish.
Okay, can. Okay, move on. What? Okay, wait, I copy this over so you can see. You want what? This one. So if I want to convert radian to degree, so first thing you ask yourself, I want to convert radian to degree. So 1 radian is 180 over pi. So pi over 6 will be this thing times pi over 6. So 30 degree. Or you can see that actually pi is 180 degree, right? I divide by 6 is 30 degrees lor. Okay, also can. So it depends on how you want to look at it for your conversion. Yeah, the other side. So if you are always unsure what you need to do, go back to the original conversion. Just like 1 meter is 100 cm. So 1 degree is pi over 180. So 75 would be this thing times 75. So it's always safer to go through the long way than to guess and then make a mistake and then lose all the marks. So this will be 1.308997 radians. So 4SF they say, so you follow the 4SF instruction they give. Yes. Because this is the conversion unit. Like 1 meter is 100 cm. Or you can tell me 2 pi is 360. Also can.
Do I need to show working for, like, I use Trigo to find this side.
Yeah.
Do I need to show working?
You can show by the diagram.
Just like this?
Yes. Okay. So we always go back to our original conversion, just like 1 meter is 100 cm. Pi radians is 180 degree. Will O-level test this once in a blue moon? So you see O-level got blue moon or not? Okay, if you flip through your 10-year series, yes, like many years, you see 1. Okay, so it depends on your luck.
So is it good for us?
I mean, if this is tested, of course, it's easy lah, right? They give you 2 marks for free.
It's so easy though.
I don't know. Okay, actually we don't know how they actually set the paper, but we keep hearing things like, oh, they set 2 years ago and then they lock the paper somewhere. So the trend is like per 2 years kind of thing. But we never really know the truth. They bundle everything like somewhere. And then they keep it for 1 or 2 years, I heard. In case anything. I think it's gone, maybe. Huh? Oh no, but PSLE is locally marked. So you go SCAB, see whether they lock for how many years. I don't know. Yeah.
You can pay $50
No.
for the paper.
If you want to review the results, that means let's say you have been a distinction student. Then when O level comes back, get a B3. You say, I want them to review your results. Then you must pay, right? Then they won't give you back your paper. They will still review at the examination board and check through your paper and then tell you, yeah, this is the result. But they will check lah. You trust their integrity that they will check. Okay, so yeah, that is how it is. Okay, anyway, tangent 1.3. Because this one has no angle, you know it's in radians. Make sure your calculator is in radian mode. Press the calculator, is 3.6022102 for SF. Cancel what radian? Yeah, this one is the many SF. Then I round off to 4 SF. I underline cause I want the 4 SF. Yes. Correct. This one is RAD. Yes. It depends on when you want to convert. Okay, I copy this here so you can see. If you want to convert to degree, you times 180 over pi. If you want to convert to radian, you times pi over 180 degree. So how I usually remember is degree, right? Okay, when you want to find your answer in degree, then the degree symbol is on top. Okay, radian, then the radian one is on top. Okay, but try not to memorize. Just go back to this and calculate. It's always the safe first one.
So question, right? Why
Yes.
not you just set math as HBL and just
As HBL? What do you mean?
It's like math like low key not that high.
Oh, can learn yourself hard.
It's compared to A math, right? E math is like it's just like one topic of A math.
Okay, sine theta is 0.435, right? If I want to find angle, I will take sine inverse. But because the angle is in radian, your calculator needs to be in radian mode. So this one, take note. You will get this. Okay, you will get this as one answer. But remember, sine, we always have two answers, right? One is theta, one is 180 minus theta. So we don't use 180, we use pi now. So pi minus this answer to find the second one. So this one, just take note. So 2SF for your answer. They want 2SF. Okay, and then this one is pi minus. So 2SF is 2.7. Yes. Yeah, when it's in radians, you must use everything in radians. Because it's... Oh, but no need to find the second one, my bad. They say until 90 degree only. So sorry, this one no need. Usually you need, but because they say only until 90 degree, we don't need to find the second one. Pi is 180, divided by 2 is 90, yeah. So you must operate in degree and radian easily. Don't worry, you have plenty of practice in trigo function. Your brain will be in radians all the time. Yes, we are almost there. Okay, let's have a short 5 minutes break. Please what? Oh, okay, I'll play. So 2 pi is 360. Yes. Pi radian is 180 degree. Yes. Okay. So if we change this to 2 pi, then we would simplify the formula for arc length to be just radius times angle in radians. Same thing here. If I were to replace this with 2 pi, if I do my conversion, then my formula for sector area is r squared theta over 2. Yes. Yes. If your calculator is in radians.
What if we accidentally do everything in degree?
If there's no sine, cosine, tangent, it won't affect your answer. It's just normal number calculation. It won't matter. Because only if you start to use tangent, cosine, and sine with an angle, then you need your calculator in degree or radian mode. If not, this one is just normal number multiplication, so no impact. Okay, when you need to change is where you need to do sine, cosine, tangent calculations.
Like the next one.
Yes. So here, this one, change this to 2 pi. So I already simplified this to be r square theta over 2. Yes. We just changed the unit basically. Okay?
Oscar.
So when your angle is in radian and you see sine in your formula, that's where your calculator needs to be changed to radian mode. Because if not, your answer will be affected. So when you see sine, cosine, or tangent, then you need to change calculator to radian mode. Okay, some students like to factorize it and solve it simply so that they don't have to write so many things. So if you take out r square over 2, it will be theta minus sine theta. So if you prefer to use segment area formula like that, you can do this. So you don't have to sub in twice. You just write one time. Okay? So this is a equivalent form. You see which one you prefer.
I think I'll just manipulate it myself.
Okay, the good news is this formula and this formula is given on the front page. R theta, r square theta over 2 and half r square sine theta. Okay, in fact the half r square sine theta is half ab sine c, so never mind, ignore it. So these two given on the front page. So there's no need to memorize. If your angle is in radian, you can straight away use from the first page. Okay? But it should come to you naturally, actually. Okay? Can so all you need to remember is this one and this one. This one is just an extension of what you already know. Yes, can. Okay, degree formula, none of it is given. This one, I changed to 2 pi. Bigger circle. This one is the same as this. So that's why I just copy this down. Okay, so let's just practice applying everything in radians. See all the three young adult, young teen playing with squishy at the back of the classroom. Don't want. I'm like terrorized by squishy. Like we went through Sparkle and my daughter saw the pau, right? Outside the, you know, they put one display over there to just sabotage the parents. And they refuse to go. And then when they open, it's just a squishy with different color pau.
Did she even get the sparkle one?
I don't know. Say, I never get the color I want. It all looks the same. Okay, but I spend money, right?
Guys have the biggest problem. According to Solomon.
Okay? Can Fine. There's always a reason to. Okay, first thing first, they give me the angle and it's clearly in radians because they put RAD there, right? So you know your brain has to operate in radian mode. So arc length formula, very easy, is just R theta. So R times theta. So my radius is 5, my theta is 2.4. So just like that. No need, because this one normal calculation. So the radian don't affect anything. So this is 12 cm. Just use the formula.
How do we know when to use the
When there's sine, cosine, tangent
That's what we
in your calculation, yes. Yes. No impact, it's just normal calculation. Okay, area formula, it's r square theta over 2. If you forget, go to the front page of the formula, right? So r square theta over 2. So you just have to put in 5 square times 2.4 divided by 2. That's all. 3 marks in your pocket. 1 mark for arc length, 2 marks for area of sector. So that's why if it's tested for end of year, you should be happy because it's there to help you score.
So the area of the sector is like, for if it's angle, it is theta over 360
Times pi r square. Yes. Okay? Can very easy formulas. Easier than the degree one, if you ask me. Okay, next one. They say, can you find this angle in radians? So that means they are telling you to operate in radian mode. So A, area of sector is r square theta over 2. So put in 125, put in your 12. So 12 square divided by 2 is just 72. So go and calculate the theta. So the math is very simple. Okay, angle, because it's in radian, give me 3SF. If you want to leave it exact like that, also can.
imaginary number.
No, the dot tells you it's a recurring decimal.
Oh.
Okay, or if you want to round off to 3SF 1.74 also can. This one is the exact form. Not the imaginary, ah.
You know,
It's
I
the
got
dot, the dot.
I for polynomial.
It's one that recurring. So it looks like I.
Okay, perimeter of the sector means they want you to add this, and then add this. So what you can do is there's 2 radius there. So 12 plus 12 and then plus the arc length. Arc length is r times theta. So my radius is 12. My theta is this value here. So you will always be required to use your answer before that.
You
So
never
don't
say
round
in
off.
radian.
They say in radians.
That one is for part A one.
Yeah. So final answer, you can also use in radian. If you don't want to use in radian, you need to find the theta over 360 times 2 pi r. But your angle, you need to convert to degree first. Then you can use this formula. Because I need to have the red line, the blue line, and the arc. Perimeter is how you walk around it. This is the arc, r theta. R times theta. Ah.
Wait, this one, I didn't get the P.
You don't get the P, perimeter. So I want to find the perimeter of this sector. It is how I walk around it. So it has to be the red line 12 cm, the blue line 12, and the arc. So you need to add 3 parts to it. So final answer is 44.83 with a dot. If it's exact, you can leave it. But if you round off, it is fine as well. KCM. Okay, so everything, every formula, the method is all the same. It's just that now you're operating in radian mode. No, because this is exact, so I left it like what it is. Yeah, recurring decimal, that's why I put the dot there. Recurring decimal is exact. It is, right? I got the dot. Because this one I use the exact. There's a 2 behind. Where? Because you use 1, I use the actual. CR minus 12. My value was this one was endless. Yeah. Okay?
So you can add the
Yes, but if you never You rounded off the value here, you put here, and then you give me 44.8. 3SF is also correct. Okay? I'm just giving you the most exact answer I can give you. So I'm telling you the method is what we have done earlier. I can give you the exact same diagram that you have done for the PMP. But my angle is in radians. Then you just need to be able to operate properly. Okay? If you don't like, if you really like, I hate radians. Then this question, you go and change to degree first. Right? Then the whole question, you can do it in your 3 formula that we learned at the first part. So you can go back to this. 180, 1 radian, 180 over pi, 2.4 radian. Then this thing times 2.4. So once you know the angle, you can operate the whole question like that. Like what we have done earlier part. Use the original formula. Don't need to do radians at all. Yes. Yes, but some people really like to see degree better than radian. They see radian, they cannot. Then you change back. I will just use the radian formula because the radian formula is short and easy.
Why did they even find radian?
It's just another way to measure lor, that is more convenient. Yeah, just like why they tell you not in cm but in meter and then in kilometer, because they want an easy way to measure things.
Did Pythagoras tell you that?
Last time, I think very olden days, when they measure like how the stars move, right? They have this equipment, but they cannot really measure like angle. They measure the distance that it moves. So when they do that, gradually that's how they evolve to using 2 pi radian to represent 360 degree. So they have a lot of measurement instrument last time, many years ago.
So you wouldn't even use radian in
Well, part of that is true, but you can appreciate it. Okay, right? Like my chat group in 2 years ago, one student suddenly say, Miss Huang, partial fraction is haunting me again at Poly. I thought I'm over certs, but it's haunting me again in Poly. So you will have, especially engineering students, you will still be haunted with AMF. Okay, like your calculus, differentiation, integration, certs, partial fraction, it will all come back. Okay?
I feel like engineering, once we graduate, right, it's just gonna be like everything on software, and then we just need to plug in the numbers, and like everything already comes.
No, but you still need to do the math.
Where?
For exam.
No, but why?
They still need you to have that skill, so. But there are students, there are non-AMF students, they are learning fresh. But you all already have the foundation. Yeah, so that's the difference.
So even technically, we don't even need this to take it.
For this one, engineering, not really this one, but it's the certs, it's the integration and differentiation. They don't require you to have AMF, but if you have, it's an advantage. Yeah. Just like that. Okay?
Can you help me?
Wait. I want to finish this one. Okay, next one. Area of sector of a circle, 1 slice. They say this one is 75 cm square. And then the arc length is 15. Am I angry, is it?
He's a gangster.
Okay, so knowing this, I want to find radius. So obviously, I will make use of arc length first. Arc length is 15, which is r times theta. So my r is unknown to me. R is unknown, Radius is also unknown, is it? Oh, okay. If both are unknown to me, I cannot use either of the formula to help me, right? But what I know is I write down the formula that is known to me first. So arc length is 15. R squared theta over 2 is 75. So what I can do is I can break this into a part. So instead of writing this, I can write like that, right? So can you see the connection that r theta is 15? So I change this to 15. That will help me remove one of my unknown. So So with that, I can find R. It's just 2 times 75 divided by 15. So 10 cm, is it? Yeah. Sorry? No, you can do simultaneous also. That means you form two equations, then you sub in one into the other. But this one just skips all the substitution, elimination. Yes. They tell me that arc length is 15. Arc length is r theta. Okay, then they tell me area of sector is 75. So r square theta is 75. Okay. So next one is I want to find theta. So the easy way out is r theta is 15. I already solved for r. So just go and find theta, which is 1.5 rad. Okay. So the math is simple. You just need to know what you need to operate as. Radian machine or degree machine. Yep. This one, no. One question only. Just like many of the chapters that you learn in Sec 4, usually there's one big question on it. And it appears in paper 2. Arc length sector area, usually it is it can be in either of the paper. Because they like to mix it with circle properties.
What's the difference between paper 1 and
Paper 1 will have majority of your lower sec and sec 3 stuff there. Paper 2 will be majority sec 4 and upper sec stuff in paper 2. Plus a PRWC question.
what's PR?
Problem in real world context. There's always one last question about 9 marks on a real world problem. That one, the candle one I gave you all last time. Something like that.
Can this topic have real world problems?
Rare, usually real world problem, they like to test what electricity bill, solar panel,
Use this in real world.
cost of something, traveling, calories, all the real life calculation that you can do. And the math is easy. It's ratio, it's percentage, it's rate. Okay, but you need to understand the story. So that's the difficulty.
Logarithmic thing. That ask us.
No, don't have. You must remember E-math student never learn A-math. Okay, next one. It says the shaded region A, B, C, D. So although on your diagram it's not shaded, but apparently what they mentioned here, this is the shaded region. Okay, it represents the surface of a pool. AD and BC are two circular arcs. AB is 3 and AOD is 2.5 radian. The length of the arc BC, this one, is 5 cm less than 5 meters less than double the length of AD. So meaning arc BC is 5 meters less than double the arc of AD. That's what they say. I'm translating this statement into this. Okay? So they say the arc BC is 5 meters less than double the length of AD. So double the length of AD, 5 meters less. So this is the statement that is translated for you. So what you can do is you can let OA be X first. Because that's what you need to solve. So I let, why? My pencil died, is it?
Yeah, another break.
Guys,
Break me. Okay, wait. Is it no battery or what? Or they have already. Let OA be X. So this is the length. Okay, let this be X so that it's easier. So arc length formula, remember, is r theta, right? So to find BC is X plus 3 times 2.5. So this is r theta. Okay, this is my r. This is my theta. Okay, then arc length of AD is the shorter one, which is X only. So 2.5x. This is the small radius times, Wrong. This is my small radius. And this is my theta. Okay? And then you minus 5 from it. So solve the math. This is just an algebraic expression. 2.5x plus 7.5 is 5x minus 5. So if you simplify, 2.5x is 12.5. X is just 5 cm. So I have found the length OA. So OA is 5 cm. Okay, so always follow what they say and then see where it leads you to. Next is the perimeter of the pool. Okay, that red zone, there's a big arc. So arc BC plus arc AD plus that 2 tiny length there, which is 3 and 3. So remember, you are walking along the pool. So arc BC, CD, arc AD and AB. So go and add this arc to find the perimeter.
So to find CD and AB, it's just CO minus DO.
CO minus DO. Yeah, but that one we already found what? Your X is 5. Already found for you, right? So to find the arc of BC is R, which is 8 cm times 2.5. Okay, the arc for AD is 5 times 2.5. So it's just these few lengths adding up together. So this is your perimeter.
Oh, so arc BC, arc AD, just arc R.
Correct. This one. Then let's have this one, the small one, and then these 2 green lengths. Okay, you will get 38.5 cm because it's perimeter. Okay, last one, I want area of that. So area of the fan shape, right, the pool, is big sector area minus the small one. So the big one is this whole big slice minus the small one below. So the big one is 8 for the radius. The angle is always 2.5 radian. So the small one is 5 cm. This one is 2.5 radian. So use the formula r square theta over 2. R square theta over 2. So remember, sector area formula is very, very, very simple.
Do you need to change from part B? Do you have to change your calculator?
No need, because it's just number calculation. It doesn't affect anything.
Then when you need to change it, just on
When you see sine, cosine, tangent. Cm squared. Okay, that's it.
formula.
Okay, so you see the last page there is a PMP. So that one again will be your homework. No need to do on foolscap paper. Just do your working here. Then we will go through this way tomorrow. Yeah, cannot meh? 5 questions only eh.
But like, I was so tired. You know, my legs will keep
Horrible. Okay, wait. I choose 2. 2 and 5.
Oh, we're just doing the 5.
Okay, do 2 and 5. Horrible. Everything also want discount. Very typical Singaporean.
For the calculate
Nah, 2 and 5.
Yeah.
the formula is